In this video, I will show you how to solve trig function equations on a given interval. Throughout this video, I will be using the facts from this trig value chart, which you should have memorized before now. So if you haven't already memorized these values, these facts, copy down this chart and use them to do the problems, but then memorize the facts because they should be in your brain. Now, cosecant squared is equal to 4. I'm trying to solve this for theta. So I think I will start by recopying this. So cosecant squared theta is equal to 4. So I need to unsquare this by taking the square root of both sides. Be careful whenever you do the square root of both sides. The solution can be positive or negative, so plus or minus. So that gives us the cosecant of theta is equal to plus or minus 2. Now cosecant is the reciprocal of sine. So taking the reciprocal of both sides, I have the sine of theta is equal to plus or minus 1/2. Okay, now the sine of what angle is equal to 1/2? So looking at the chart to jog your memory, the sine of pi over 6 is 1/2, or 30 degrees, but I'm going to stick to radians. So the sine of pi over 6 is 1/2. That tells me that the reference angle is pi over 6. Alright, that's just the reference angle, not the final answer. Let's draw a diagram of all the angles that have pi over 6 as a reference angle. Okay, all 4 of these angles has pi over 6 as a reference angle. All right, this is pi over 6 right here. Now we're talking about sine right now, and the sine function is a y value on the unit circle, and y values are positive in these two quadrants and negative in these two quadrants. But since we have plus or minus, we actually want all 4. So this first one is pi over 6. Maybe I'll just make a little list underneath. This first position is pi over 6. And then the next one is 5 pi over 6. And then this would be 6 pi over 6. So this one is 7 pi over 6. Alright, if we went all the way, that would be 12 pi over 6. So this is 11 pi over 6. Alright, we want all 4 of these. And let's see. Pi over 6, 7 pi over 6, 11. That's D. So this is multiple choice. So in this case, the answer was D. For problem number 2, I don't like the fact that I have 2 different kinds of trig function. I have secant and I have tangent. So I'd really like to rewrite this. There's a connection between secant and tangent. So here's another set of notes, set of facts. These are Pythagorean trig identities. You need to have these memorized as well. You should be able to take a sheet of scratch paper and create this chart within 1 minute. Okay, so I'm going to assume that you've done that. You go ahead and make that a reality. And in the meantime, let's use it. So notice the lower left-hand yellow here. It says that secant squared is equal to 1 plus tangent squared. That's what we're going to use right now. So I'm going to replace secant squared with 1 plus tangent squared. In that way, we have only tangent instead of secant and tangent. So I'm noticing that I have tangent squared and I have tangent. This will be the type where we get 0 on one side. So I am going to subtract 2 tangent theta from both sides. Alright, and I'm also going to rewrite this in the other order. I'm going to put tangent squared first. So this will become tangent squared theta minus 2 tangent theta plus 1 is equal to 0. So this is really a trinomial that will probably be factorable. So I'm going to just go ahead and try to factor this in the normal way that we would factor a polynomial. For example, tangent squared will be tangent times tangent. Alright, now skip over to this third term. 1 is only factored as 1 times 1. Now inner plus outer must equal the middle. Inner, I've got 1 tangent theta. Outer, I've got 1 tangent theta. I'm trying to get a middle of negative 2 tangent theta. I can achieve that if both of these are negative. That'll make negative 2 tangent theta. So that means both of these have to be negative. Also, negative 1 times negative 1 is positive 1, so that works out great. I think I'll erase this though. Okay, so now I'm going to set each one of these factors equal to 0, except they are the same, so I don't need to do it twice, because that would be silly. So tangent minus 1 is equal to 0. Adding 1 to both sides gives me tangent theta is equal to 1. So the tangent of what angle is equal to 1? This should be popping into your head, but just in case you're struggling, the tangent of pi over 4 is equal to 1. Again, that tells us the reference angle. So the reference angle is pi over 4. Okay, so let us consider a chart. Alright, here's a diagram of all of the multiples of pi over 4. And these are the reference angles right here. Okay, now 2 of these are positive and 2 of these are negative. Tangent is positive in these 2 quadrants, and tangent is negative in these 2 quadrants. But here we have tangent is positive 1. So we only want the 2 positive versions. So that first one is the reference angle itself, pi over 4. But then this one over here is 5 pi over 4. Alright, so that is it. Let's see, pi over 4 and 5 pi over 4. So the answer is A. So for number 3, I like the fact that we have only cosine throughout. So I'm just going to jump right in. Since I see cosine and cosine squared, that tells me that I need to get 0 on one side and try to factor. So I'm going to add 5 cosine squared theta to both sides. And I'm also going to add 1 to both sides. So that'll give me 0 over here. So when I rewrite this, I'm going to put the squared term first. So 5 cosine squared minus 3 cosine squared is 2 cosine squared. So I have 2 cosine squared theta. And then there's my plus 3 cosine theta from right here. And then the plus 1 that I just brought over. And that is equal to 0. Now hopefully this is factorable. So let's dive in and try to factor it. 2 cosine squared theta can only factor as 2 cosine theta times cosine theta. 1 can only factor as 1 times 1. Now the key to the Burton method is inner plus outer equals middle. So inner, these two, I have 1 cosine theta. Outer, I have 2 cosine theta. This has to give me the middle of 3 cosine theta. And that will happen if I just leave everything positive. That makes 3 cosine theta. So that means these two will be positive. Alright, I'm just going to go ahead and erase this little part. So now I'm going to set each of these factors equal to 0 to get my solutions. So on the one hand, we have 2 cosine theta plus 1 is equal to 0. And we have cosine theta plus 1 is equal to 0. Alright, so on this side I'm going to subtract 1 from both sides. So that's going to give me 2 cosine theta is equal to negative 1. Dividing both sides by 2 gives me cosine theta is equal to negative 1/2. So let me go ahead and follow through on this part. The cosine of what angle is equal to 1/2? I'm ignoring the negative sign for now. So remember this. The cosine of pi over 3 is 1/2. So that tells me that the reference angle is pi over 3. Whoops. Alright, I want to do this off to the side here. So the reference angle is pi over 3. So here's my little diagram like I do. I'm showing this diagram just so you can see my thought process, but really you should be imagining this in your mind and not really drawing it every time. So these are the 4 places that these are the 4 angles that have a reference angle of pi over 3, which is right here, pi over 3. Now, cosine is an x value on the unit circle, so x values are positive in these 2 quadrants and negative in these 2 quadrants. But here we have cosine equal to a negative value. So that means we want these 2. Boom and boom. Those are going to be the answers. Alright, so that means this one up here at the top is 2 pi over 3. And this one down here is 4 pi over 3. Okay, now let's jump over to the cosine plus 1 equals 0. Subtracting 1 from both sides, we have the cosine is equal to negative 1. So where will that be true? Well, this is a quadrantal angle. This is not on the chart. But when I say a quadrantal angle, I'm talking about angles that fall right on the x-axis or the y-axis. So in this position, the coordinates of this point are 1, 0, and this is 0, 1, negative 1, 0, and 0, negative 1. Cosine is the x value on the unit circle. So since we're only looking at the x value, we're just looking at this. Okay, so the cosine of which angle is negative 1? So obviously we're only talking about this guy right here. And this is pi. Alright, so I'm going to add pi to the list. So these are the 3 solutions. 2 pi over 3, 4 pi over 3, and pi. which is B. So the answer is B. So for problem number 4, we have two different types of trig function, cotangent and cosecant. I don't like that. I want one kind of trig function, but I know a connection between these two trig functions. And if you look at the trig identity chart, which you should have memorized, you see that 1 plus cotangent squared is equal to cosecant squared. Alright, so I think I will just replace cosecant squared with 1 plus cotangent squared. So if I do that, I'm going to have negative 3 is equal to 3 cosecant, alright, plus, wait, we have cotangent squared. So I misspoke a little bit. So we have cotangent squared. So I need to modify this a tiny bit. If I, well, I guess all I need to do is look at the blue. So cotangent squared is cosecant squared minus 1. So that's what I'm doing. Alright, so cosecant squared minus 1. I can just squeeze it in there. Alright, there you have it. So now I'm going to get 0 on one side and then solve this. So of course I'm going to add 3 to both sides. And then I'm going to rewrite this in the order that we're more comfortable with. So I'm going to put cosecant squared first. So I will have cosecant squared theta, and then plus 3 cosecant theta, and then negative 1 plus 3 is 2, and that is equal to 0. So I'm betting this is going to be factorable. I'm going to have to give up and get the space going over here. I bet this is going to be factorable, so let's go to it. Cosecant squared can only be factored as cosecant times cosecant. 2 can only be factored as 2 times 1. Now the key to my method is the phrase inner plus outer equals middle. Inner, I have 2 cosecant theta. Outer, I'm talking about these two right here, 1 times cosecant theta is just 1 cosecant theta. These have to add up to the middle term, which is 3 cosecant theta. I will get that if I just let these be positive, which means that both of these would be positive. And positive 2 times positive 1 is positive 2. So that works out great. So now we factored it. So now we will set each of these factors equal to 0. So we will have cosecant plus 2 is equal to 0, and cosecant plus 1 is equal to 0. So subtracting 2 from both sides, I will have cosecant is equal to negative 2. Subtracting 1 from both sides, I will have cosecant is equal to negative 1. Cosecant is the reciprocal of sine. So taking the reciprocal of both sides, I have sine theta is equal to negative 1/2. And I have sine theta is equal to negative 1. The reciprocal of negative 1 is still negative 1. So let's solve each of these little equations. So the sine of some angle is negative 1/2. Let's start with positive 1/2 so we can find the reference angle. The sine of what angle is 1/2? Well, hopefully you know that that is pi over 6. Sine of pi over 6 is 1/2, all right? You should have that memorized. So that tells me that the reference angle is pi over 6. okay, for the left hand side here. So, and again, you should be able to do this in your head by now. Should I? Okay. Look, here's what sometimes I sit here and I draw all of the lines like this. Oh, okay, that was not the best job. But I draw all 6 lines and then I draw the 4 of them. Okay, but even if you are going to draw a diagram, you should be able to get away with just drawing the 2 angles that are above and below the x-axis like this. Alright, if you're going to draw a diagram at all, this is the quicker version. Now these are my reference angles of pi over 6. So that means that this first one is pi over 6. Now, if I went all the way over to here to pi is the same thing as 6 pi over 6. So that makes this one 5 pi over 6. And this one is 7 pi over 6. If I went all the way around to 2 pi, that would be the same thing as 12 pi over 6. So this is 11 pi over 6. So you should be able to do this in your head. Just picture this picture and picture these 4 positions. You should not have to draw it every time. Anyway, the sign in this case is negative 1/2. So which 2 of these will sign be negative at? Sign is a y value on the unit circle. So y values are negative down here. So the sign of either one of these will be negative 1/2. So these are 2 solutions. Okay, so we have theta is equal to 7 pi over 6 or 11 pi over 6. Okay, now how about this other one, the other equation? Well, this is a quadrantal angle. It's not a chart angle. So let's look at the quadrants. Okay, the coordinates of this point are 1, 0. This is 0, 1, -1, 0, and 0, -1. Sine is a y value. So we should only be looking at the y values. And the sine is -1. So that is only going to be right here. Okay, and that is 3 pi over 2. So these are the answers: 7 pi over 6, 11 pi over 6, and 3 pi over 2. Alright, which is A? Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.